Okay guys, now is another thing to practice. I want to do another one with you. I want to do number 12. It says y equals the square root of x. That's our original relation that we're working with. So we're going to be asked to write the equation of the inverse relation. First of all, let's take a look at what the graph will look like. The square root of x, I know it has a starting point at 0, 0, and it's gradually increasing. So it looks something like that. So let's talk about the domain. What's the domain of this? Well, the domain looks like it is starting at 0, but it's going all the way to infinity. That's where x is defined. Now what about the range? Well, the range looks, again, like it's on the y-axis. I'm looking at the y-axis. Like it's starting at 0 and it's going all the way up to positive infinity. Okay, that's exactly where it will be defined. So, in this case, this is pretty easy because the domain and range are the same thing. So, in my inverse relation, I know that my domain, it becomes the range of the original relation. So it would be 0 to infinity. And my range becomes the domain of the original relation. So that's 0 to infinity. Okay. That's easy because, the reason why I say it's easy is because these guys are the same thing. So, let's solve for our inverse relation. Our original relation was y equals the square root of x. So our inverse relation would be switching x and y first. So x equals the square root of y, and then solving for y. So how do I get rid of a square root? Well, I square both sides. So that's exactly what I'm going to do. So I have x squared equals y. Okay, so x squared equals y. That is our inverse relation. But let's talk about this. What is the graph of y equals x squared? It's our inverse relation. The graph of y equals x squared, it's a parabola. It's just our parent function for a parabola, right? Okay, so what is the domain of this graph? Well, to me it looks like the domain is all those real numbers, negative infinity to infinity, right? I mean, it's being defined all the way as I go this way and all the way as I go that way, because it keeps getting bigger. The range is just 0, including 0, all the way to infinity. Now, do you guys notice a problem with this graph? What would be the problem? What would our problem be? Why would this not be the graph of the inverse relation? Well, the reason why is because what does our domain for the inverse relation have to be? Our domain for the inverse relation has to be 0 to infinity. We already have our range. We know our range has to be 0 to infinity. And I looked down here and I said, okay, well, it checks my range is 0 to infinity, but my domain is not. My domain for this graph right here is negative infinity to infinity, but I want it to be just 0 to infinity. Okay? So the way to do that is we restrict the domain. We say our inverse graph function is just that guy that I highlighted in green. It is the equation y equals x squared with a restricted domain. The domain restriction. TRICTION. Sorry guys, that's terrible. But it's a domain restriction, okay? A restriction. Why is it a restriction? Well, Restriction means to hold something back, right? If you're restricted from doing something, you can't access that. Here, our domain was supposed to be negative infinity to infinity. We found out that it can only be 0 to infinity in order for it to be the correct inverse. So we are restricting the domain. We're saying, hey, this side, you no longer are part of my inverse function, and I'm only going to include this half of the graph. So it is the graph y equals x squared with a restricted domain.